Kurtz here for Easy Access Math, and I have a short lesson here on finding perfect squares within, which would be simplifying radicals. And to do this, what you need to know and what you need to do is know your perfect square numbers and be aware of the multiples of perfect square numbers. Now, my perfect square numbers: 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. And these are derived by multiplying 1 times 1. These would be the roots. 2 times 2, 3 times 3, 4 times 4, 5 times 5. These numbers in red are the square roots of your perfect squares. 10, 11. And you could keep going just by multiplying a number by itself. If you wanted the 16th, it would be 16 times 16. And you could just keep this list going. It's important to be aware of your perfect square numbers. Now, these numbers are not perfect squares. Any perfect square, when you put a square root around it, is a number. Put a square root around 49 and your root is 7. These don't have perfect square roots, but you could simplify some of them. You could break them down. Sometimes you can't, and I'll show you that, but if you take a look at 60, you want to know the highest number on this list that can go into 60. Now, the highest number on the list of perfect squares that can go into 60 is 4. If you're not sure, just try dividing. Try dividing 60 by 9. You're not going to get a whole number. And if you don't get a whole number, then that number does not evenly go into 60. So it's not something you can simplify with. But 4 does go into 60. 4 goes into 60 15 times. So I can break down the 60 as 4 times 15. See that? And the 4 comes out not as 4, as the root, as a 2. So you have to get the square root. Either you'll remember what the square root is. If you are using a calculator, hit your square root key just to be sure. Put the 4 in, hit the square root key. It's the number you get, the 2, that comes out, not the 4. The 15 could not be rooted, so it stays in as 2 radical 15. Take a look at that 90. The highest number on this list that goes into 90, 9. It's 9 times 10. 9 comes out as its root, which is 3. 10 stays in. That gives me 3 radical 10. How about 21? You know, 21 has multiples. 3 times 7 is 21. But it doesn't have any perfect squares that go into it evenly. And so this just stays. It can't be simplified. I want to show you one more number. It's a little tricky. 72. The square root of 72. You could break that down, but you need to be careful. Many people will look at that list and say, yes, 9 times 8. 9 times 8 is 72. But I said you need the largest perfect square. So even when you get that 9, keep trying. Make sure nothing over 9. Now, you're not going to need to go over 81 because that's already too much. So just make sure that 64, 39, 36, 25, 16, maybe one of those goes into 72. You want the largest perfect square. And if you chose 9, things could get messy because 36 goes into 72 twice. You want to be sure that nothing larger than the number you choose as far as one of these perfect squares can go into your number, so be careful. 9 goes, but 36 also goes. And life is a lot easier if you get the largest perfect square when you're simplifying. And it would be 36 times 2, the 36 comes out as the root, which is 6, leaving me with 6. This 2 stays in, 6 radical 2. So even though 9 times 8 were multiples of 72, 36 times 2, those were the ones to go with because that's the largest, 36, the largest perfect square that went into 72. So that's our lesson, our quick lesson review of perfect squares within and simplifying radical numbers, looking for those perfect squares within radicals that are not perfect squares themselves, but do have perfect squares as multiples in them.